Okay, in our last class, we were able to prove that we have three major equations of rectilinear motion. The first one is that V is equal to U plus AT. Second one is S equal to UT plus AT square over 2. Then the last one, let's prove the last one. V square, if V is equal to U plus, if V is equal to U plus AT, square the both sides, V square equal to U plus AT all square. If you square the both sides, you are going to have V square equal to U plus AT in bracket U plus AT. So we're going to have that V square is equal to U times U square, if you open the bracket, U times AT, UAT, plus AT times UAT, plus AT times AT, A square, T square, right? So we have that V square is equal to U square plus UAT is what? 2UAT plus A square, T square, is it not? So we're going to have that V square is equal to U square plus what is common here. If I bring out 2A here, what remains? UT remains plus what will remain here? A remains because there is already A, and T remain divided by 2 because there is no 2 in this place. If I open this bracket now, if I multiply this by this, you're going to have 2AUT or 2UAT as the case may be. This times this is 2UAT plus 2 times this is going to give you 2A square T square, is it not? All over 2. So this 2 will still cancel 2. So that this will still be the same as this. So that's why we have the 2 there. You understand? So but UT plus AT square over 2 is equal to S. So V square is equal to U square plus 2A. Everything in the bracket is equal to X. That is equation 3 in equations of motion. So equations of motion is this is equation 1, this is equation 2, equation 3 is V equal to U, V square equal to U square plus 2AS. That is equation 3. Okay, please take note of this. If a body starts from rest, that means the initial velocity of the body is 0. U is equal to 0. If you are doing calculation and you heard or they tell you that a body starts from rest, when a body starts from rest, U is equal to 0 because the body was at rest before moving, so it has no initial velocity. If a body or when a body comes to rest, it's no longer in motion. Therefore, the final velocity is 0. V is equal to 0 because the body was moving but no longer in motion. Therefore, the final velocity is 0. If you hear that when a body moves with constant velocity, acceleration is equal to 0. Why? No change in velocity. Acceleration is change in velocity over time, is it not? So when the body moves with constant velocity, acceleration is said to be 0. It's also important to understand that a body in uniform velocity is not the same with the constant velocity. A body is said to be in uniform velocity if it covers equal displacement at equal time interval. If I have a graph of velocity of displacement, over time, when a body covers equal displacement at equal time interval, the displacement time graph is going to be a straight line graph. It's going to be a straight line. Take note of that. This gradient is said to be a uniform velocity. Why? If a body after 2 meters, it takes the body 1 second to cover 2 meters. If a body covers 2 meters in 1 second, This body says to be in uniform velocity if it covers 4 meters in 2 seconds, if it covers 6 meters in 3 seconds, if it covers 8 meters in 4 seconds. What it implies is that at every 2 meters, it spent 1 second to cover it. This is says to be a uniform velocity. If you plot a graph of uniform velocity, you're going to have a straight line graph. If here is a displacement s, here is time, and you have here 2, 4, 6, 8. You have here 1, 2, 3, 4. When it is 2, it is 1 second. At 4 meters, it is 2 seconds. At 6 meters, it is 3 seconds. At 8 meters, it is 4 seconds. So it's a straight line graph. So this is a graph of uniform velocity. A graph of uniform velocity. So we have what we call uniform velocity. We also have what we call non-uniform velocity. In non-uniform velocity, the body does not cover equal distance at equal time interval. The body does not cover equal distance at equal time interval. The body does not cover equal distance at equal time interval. In that case, you are going to have displacement over time. It can go up and come down or go up again. When you have displacement over time, you remember that the gradient is a velocity, so it's a non-uniform velocity because it is not a straight line. Remember, why is it velocity? Because velocity is distance over time. You have known that. In the same way, we also have uniform acceleration. We also have a non-uniform acceleration. What makes an acceleration to be uniform, non-uniform? An acceleration is said to be uniform if it covers equal velocity at equal time interval. Here will be velocity over time, no longer displacement over time. It covers equal velocity at equal time interval, so it's going to be a straight line. The gradient is a what? A uniform acceleration. If it's non-uniform acceleration, it must be velocity. It must be graph of velocity over time, so that the gradient will be acceleration. But if it's not a straight line, it is a non-uniform acceleration. Non-uniform acceleration. How do you know that a graph is the gradient of a graph is acceleration? If it's velocity time, the gradient is acceleration. If it's displacement over time, the gradient is velocity. Do not forget that. If the motion is under gravity, what does that mean? If the motion of the body is under gravity, that means it implies that the motion is a vertical motion. It's either going up or coming down and is affected by the gravitational force, like I told you in the last class. Is it not? So motion under gravity, if V is equal to U plus AT equation 1, the acceleration becomes gravitational acceleration because the acceleration is affected by the force of gravity, is it not? So the acceleration depends on G. So A becomes G. If it's going up, you use, because it's going against gravitational force. If the body is thrown up, you use minus. If the body is coming down, you use plus. So V is equal to U plus or minus, depending on if the body is going up or if the body is coming down. Going up against minus, coming down, going up is minus, coming down is plus. Take note of that. GT, no longer A. This becomes equation under gravity, equation of motion under gravity. The next equation of motion we have is that S is equal to UT plus AT square over 2. Under gravity, distance becomes height, is it not? So height is equal to UT plus or minus G. A becomes G, T square over 2, is it not? Then you now have V square is equal to U square plus 2AS, which is the third equation of motion we proved. In this case, it will still be the same. V square equal to U square plus or minus, depending if the body is going up or coming down, as you're going to see in our calculations. 2, A becomes what? G, S becomes what? H. Distance becomes height. Under vertical motion, distance becomes height. So this becomes the equation of the under gravity. Under gravity changes to this. Under gravity changes to this. Under gravity, this changes to this.